we just talked about molarity. Now when we're talking about molality and then normality, so we move to the next. So what's the molarity of a solution that contains 6.3 grams of NaOH in 300 ml of water? Molarity is equal to the number of moles over weight of the compound. So we have molarity will be equal to 1000 if is in cm cube times mass over m w, which is w. Now this m is mass of solute dissolved. This is the mass of solvent used. Then this is the weight of the solutes. Okay, so now let's solve this question. Say what is molarity? Molarity of a solution, what is the solution? NaOH in water. So we have times 6.3 over m. Now the mass of this of solvent, which was actually 300, times the weight of solutes. Now what was the weight of solutes? 40, which is NaOH. So this is actually 40 grams per mole. 40 grams per mole. So our molality will be 0.525 molality. Now this is all question 1. Now let's take a look at question 2. Question 2 says what is the molality of a solution of 40 grams of naphthalene? Now naphthalene is actually our solute, so we have 1000 times naphthalene. Now the mass of the solute, which is 40 over solvents, mass of solvents used, times the weight of naphthalene, 128. So what should our answer be? This is actually 0.868 molality. Okay, so strict, we are going to normality. Normality is actually simpler compared to molality. Now, this is a straightforward formula for calculating normality. Normality is molarity times number of reacting units. Normality is molarity times number of reacting units. Now, if we have a compound like HCl, now we have H2O, H2SO4, H3PO4. What is the basicity of this acid? We have it to be 1, this 2, this 3. So now, this is the N, the number of reacting units. So if we have our molarity, if we calculate our molarity, we have a particular value, we multiply it by the reacting units. So it is either if any of this acid or any other acid, find the basicity of the acid, then multiply it with the molarity, you get the normality. So let's take a look at this question. It said determine the normality of a 300 cm3 solution made by dissolving 40 grams of H2SO4 in water. Okay, so now we already have the idea for calculating molarity from our last class. So if you calculate the molarity, from our previous class. We calculate the molarity multiplied by the reacting unit. So let's calculate for molarity first. Molarity is C is equal to the mass. What is the mass? 1000 times 40 over the molar mass of the compound, 98, times volume, 300. So we have this to be 1.36 molarity. So instead we find our normality. So normality should be molarity 1.36 times the ask of H2SO4. So H2SO4 will be times 2. So this should give us 2.72 normality. Now this is the answer for this question. Okay, so now we'll strictly be going straight to chemical equilibrium. Now for a reaction, let's take any reaction from here. We have, let's say, A plus B giving us C plus D. Now the equilibrium constant for this reaction will be, this is A, B, C, D. Now the equilibrium constant for this reaction would be concentration of C raised to the power number of mole of C times the concentration of D, so that the number of mole of D, over the concentration of A, this is the number of mole of A, then concentration of B is the number of mole of B, which is this. Now this is the equilibrium constant for this. Now if you were asked to find the Kp, if you have your Kc already, or you were given your Kc already, or you were asked to find the Kp, if you solve for the Kc, now this is the formula for Kp involving Kc, change in N. Now this change in N is the summation of the number of moles of the gases at the product side minus the summation of the number of mole of the product. So now this is for Kp. Now this works when you are given the Kc and asked to find the Kp. Now for normal Kp, so you find the Kp of a reaction. Kp of a reaction is the mole of C raised to the power C, taking this reaction, then at the same time D raised to the power D over the number of mole of A raised to the power A, then the mole of B raised to the power B. Now this is for Kp when the Kc is not given. Now let's nitrogen gas or nitrogen in the gaseous form react with chlorine in the gaseous form to produce NCl3. Now that is also a gas. Now at equilibrium, the concentration of each gas were found to be, this was equal to this, this was equal to this, and that was equal to that. So you calculate the Kc. Recall that this was a reaction. They said okay, we have N2 plus Cl2, we have to give NCl3. Now can we balance this equation? Sure we can. So we have coming to be 3 here. Let's assume we have 3, so we have 3, sorry, 2, 2. So here is 6 is 6. So that nitrogen here is 2. So this is the balance equation for this reaction. Okay, so now Kc will be equal to the concentration of N, the concentration here, now this is the Kc for this reaction. Now we were given the concentration of N to be 0. Concentration of this N2 to be 0.15, Cl2 to be 0.25, then NCN3 to be 0.5. So let's place it into this equation. So we have what the concentration we had for this 0.5 square over N2. N2 was 0.15, then times Cl2 0.25 raised to the power 3. So now when the Kc for this reaction, T would be 106.67. Now this is the answer to question 1. Question 2 says, if the Kc of the below reaction, this is reaction is 9.60 at 300 Celsius, what is the Kp at this temperature? Now we're given the Kc and we're asked to find the Kp. Now recall that Kp is equal to Kc times ROT raised to the power change in moles. So now we now have Kp is equal to what is the Kc? Kc was 9.6 times ROT. RO is a constant which we all know to be 0.082. So 0.082 times the temperature. Temperature 300 degrees Celsius plus 273, that is 573. So we have it to be 573. Raised to the power change in mole. Now this is the reaction. This is 2, 1 plus 3, which is 4. Then it will be 2 minus 4. 2 minus 4. So we now have our Kp will equal to 9.6 times 0.082 times 573 raised to the power minus 2. Now our Kp is 4.34 times 10 to the power minus 3. Now this is the answer to question 2. Now, given the value of K for this reaction shown below, what is the value of K for the adjusted reaction? Now this question is quite tricky, but as easy as the word easy. Let's draw something. We have this to be, let's find the Kc of this. This should be concentration of NO2 raised to the power 2, then over concentration of NO raised to the power 2 plus times concentration of oxygen raised to the power 1. So this is for K1, this is for the Kc for this reaction, and it was equal to 100. It was equal to 100. Now they're asking us what would it be for this reaction. We won't know until, let me show you something. For this second reaction, we have Kc to be NO2, the number of mole is 4, we have NO2 raised to the power 4 over NO raised to the power 4, then O2 raised to the power 2. Now what do you observe here? You should know that this reaction, this you can find this thing inside this place. Now, how do you do it? This is the same thing as now. If you square everything here, you will get this back. This time this will give us 4, this time this will give us 4, this time this will give us 2. So if you square this part, if you put this equation into it here, it's the same thing. Now squaring this one, you get this side. So now, what will our K be now for this reaction? What will our K be for this reaction now? Since we have, they said this was equal to this, meaning everything we have here is 100. So KC will be equal to the KC, let's assume, yes, K1, okay, let me say K, yes, K1. So K1 will now be equal to K squared, which is equal to 100 squared. So this is the answer to this question. Now, assuming this place was, assuming it was halved, assuming it was adjusted to 1, then here was 1 over 2, and here was 2. It is actually going to be the square root. They are actually going to be the square root for this. So, why, if they said this reaction was reversed, you will now find the inverse of this. You find the inverse of this value. So that's the answer. So that's how to calculate this question that comes in this form of chemical equilibrium. So now let's take a look at this last question, question 4. Let's start here. Solution. Now they said 20 mole of NaCl is placed inside an empty 4-liter container at equilibrium. Now, this 20 mole of NaCl is placed inside an empty container. Now, at equilibrium, 8 mole of Cl2 was found to be in the container. Calculate the value of Kc for this reaction. Now, this type of reaction is quite different from what we have been solving. Now, this is the solution, but let's continue. Let's start up here. Now, let's draw up something. This is 2 mole ratio 2 ratio 1. So let's draw initial, central, then the equilibrium points. Now at the initial point, we have our concentration of this compound. They say 20 mole of this inside an empty container, which is 4 liter. 4 liter is the same thing as dm³. So the number of mole is equal to CV. So C will now be equal to the number of mole 20 over the volume 4, which is equal to 5. So we have here to be 5 mole. So at this point, at the initial point, the rest all of them are 0. They are 0. So now, at this point, we have 2 mole of this. Now, what should we understand about chemical equilibrium? If this part is to be adjusted, now this equation is at equilibrium, meaning let's assume something. Let's draw something. Let's assume water is being poured into this part. So if let's assume 1 liter of water. 1 liter of water is poured into this place. The number of water that will flow into this part, if here was give us a range of 5, then here is 1, 2, 3, 4, 5. Then the same thing, 1, 2, 3, 4, 5. Now, if water is poured into this reaction, into this container, the number of water that will flow into this place, we go to a point where they are equal, where they meet at equal points. If the water is filled to the brim, then they open this blockage, allow it to flow inside. It will go down to the same point. Let water be equal, they'll always be equal. So if an extra water is being poured, this will give this again in order to make its equilibrium position, to make them equal. So as well, if water is being poured into this part will give it to this side, so that they will be at an equilibrium position. So this is what this equation is trying to talk about. So these 2 moles is giving this 2x. Then we have here to be 1x, 2 moles, then this 1x, that is 1 mole there. So now at equilibrium position, we have it to be 5 minus this. This is minus because it is giving out what it has, the 2 moles it has, to this. And this is accepting. So taking what it can take, which is 2 moles, and this 1. So we have at equilibrium position, we have 5. At equilibrium point, we have 5 minus 2. 5 minus 2x. Then here we have 0 plus this will give us 2x. 0 plus this will give us x. So now, how do we calculate our Kc? Now, the next further said, at equilibrium, 8 mole of Cl2 was found to be in the container. Now, for Cl2, concentration of Cl2 during this equilibrium position was found to be, the concentration will now be 8 mole divided by 4, which is concentration equal to N over V. So we have 8 over 4, which is equal to 2. So we have our concentration of Cl to be 2. So therefore, X is equal to 2. So now, what will now be the concentration of NO2? Concentration of NO2. So we have concentration to be 2. So is equal to X is equal to 2. The concentration of NO2 will be equal to 2x, so 2 into 2, which is equal to 4. Then concentration of this part, NOCl, at equilibrium, NOCl will be equal to 5 minus 2 into 2, which will actually give us 5 minus 4, which is 1. So now these are the concentration of each compound in this reaction. Now let's find the Kc. Now recall that already at equilibrium we have our value. Now let's say we find the Kc. So Kc will be equal to concentration of the reactant. So we have the product NO2, NO raised to the power 2, then Cl2 raised to the power 1 over NOCl, concentration of NOCl raised to the power 2. So now Kc will be equal to concentration of NO2 was concentration of NO2 during equilibrium is 1. So we have 1 square times conjugation of Cl2 was 2. Cl2 was 2. So we have 2 over conjugation of NaCl. So the conjugation of NO was 4. Was 4. Then NaCl, which is 1 square. So we have 16. 4 square is 20 times 2, which is equal to 32. Now this is the value for the Kc of this reaction. Now, when you see questions like this, you have to go through this process as easy as this. Now, one thing you should note, in Kc, you are dealing on concentration. That's why I have to convert this formula to concentration. So that's all for this type of question. There are some other questions that are similar to this, where this one, so it will be in this form: 2NO plus Cl2, giving you this, giving you 2NOCl. And will give you this parameter, and this with this reaction, you should find the Kc of this reaction. This type of reaction will lead you to quadratic equation. It's as easy as the word easy. Your calculator is there to help you. At the same time, very easy to solve. Alright. Now, potential of hydrogen. Now, pH of strong acid. This is actually pH of strong acid. Now, I'll give you a formula to solve for pH of strong acid, and then we'll move on to pH of buffers, then that of weak solution, and so on. Then we'll move on to the KSP, solubility product. So now, let's say, first of all, pH, let's note that pH is equal to minus log concentration hydrogen ion, POH is equal to minus log concentration OH ion, hydrogen concentration of hydrogen ion times concentration of is equal to 10 raised to the power minus 14, whereas pH plus POH is equal to 14. Now this formula, also this formula works at a temperature 25 degrees Celsius. Okay, so if you are given the concentration of hydrogen ion and you are asked to find the pH, you just place in the concentration, you put minus log of the concentration given. If it is 0.05, you put it here, you get your pH. Okay, so now if you are given your hydrogen ion, concentration of hydrogen ion, you have to find your OH. You divide 10 raised to the power minus 14 by the concentration given. As easy as that. If you are asked to find your POH, given this, you place in your value. But if you are asked to find your POH, this was not given, but this was given, hydrogen ion. If you first find your pH, then pH plus POH is equal to 14. Minus 14 from it, you give your POH, and so on, as easy as that. So let's take a look at this question. Let's take a look at this question. It said, calculate the pH of seawater given that its OH is 5.0 tested per minus 4. So now they were asking us pH, whereas they gave us a hydroxyl ion. So now what do we do? First of all, since we know that pH, pH plus POH is equal to 14. So pH is equal to 14 minus POH. And we're given the OH, so we can quickly find the POH. Where POH is equal to minus 14 minus log the concentration given of OH, which is 5.0 times 10 to the power minus 5. minus 4. So our pOH would be 3.3 approximately. So therefore, instead of calculate the pH, therefore pH plus pOH is equal to 14. So pH is equal to 14 minus pOH. So pH is equal to 14 minus 3.3, which is 10.7. So our pH value is 10.7. Alright, so now question 2, quickly. Calculate the pOH of a certain soft drink. The pOH of a certain soft drink was found to be 10.6. 10.6. This. Calculate the pH of a certain soft drink. The pOH. The pH of a certain soft drink was found to be, so we have pOH is equal to 10.6. So therefore pH is equal to 14 minus pOH. So 14 minus 10.6, which is equal to 3 point something. That's 3.4. Now this is the answer to question A. Now it said calculate the hydrogen ion of the soft drink, which is the concentration of the hydrogen ion. Since we have our pH to be 3.4, recall that pH is equal to minus log concentration hydrogen ion. We have to find hydrogen ion. So how do we make hydrogen ion from the formula? First of all, multiply both sides by minus so that you can take this minus to this side. So we have log concentration hydrogen ion is equal to minus pH. Now, this logarithm for calculating pH are in base 10. Base 10. So moving it like this, taking this log away from here, we have it to be hydrogen ion, concentration hydrogen ion will be equal to, either you say antilog of this or you say 10 raised to the power minus pH. Antilog is something as 10 raised to the power something. So 10 raised to the power minus pH, which is 10 raised to the power minus 3.4, which is actually 3.98 times 10 to the power minus 4, which is approximately 4 times 10 to the power minus 4. Now this is the concentration hydrogen ion of this question. So now let me go to pH of buffer solution. It is quite similar to this but different. So now we have jumped into pH of buffers. Now let's take some formula to note for pH of buffer. Now, first of all, pH is equal to pKa minus log concentration of salt over the concentration of acid. Plus. Now, if it is either you write it in this form or you write it as pH is equal to pKa minus now what is the difference here? We have minus here, we have plus here. What makes it different? Salt, concentration of salt or concentration of acid. Yes, concentration of acid or concentration of salt. That's what brought the change. So now, this is for acids, pKa for acid. Now, for the base, we have pOH is equal to pKb plus log or it be in this form. Now any of these, now this is for POH, now this is for pH. So we are likely to be used to any of them. You can get used to any of them. You can either to solve, you can either to solve. So you find pH, you can either use this or this. So you find PO, either use this or this. So now KB, KA is the same thing as, so therefore KB is same as, so therefore KA times KB will give you 10 to the power minus 14 at a certain condition. Now PK is the same thing as minus log and I told you this is the same thing as KA, so we have it to PKA, the same is now minus log KA. Then PKB is equal to minus log KB. So that's all you should note. And these formulas work under a certain condition, like you should know, which is 25 degrees Celsius, almost similar to that of pH of strong acid. Now let's solve some questions. Calculate the pH of a buffer that is 0.03 m in CH3CO, which is ethanoic acid, and 0.09 m in CH3CO, and which is salt, which is sodium ethanoate. Now, buffers talks about weak acid and its salt, mixing weak acid and its salts, then or weak bases and its salts. So now that's what I'm trying to talk about here. So they said calculate the pH. Now recall that pH, they gave us the Ka, so what kind of pH? Remember that pH is equal to pKa plus log concentration of salts over the concentration of acid. So pH is equal to the pKa. pKa will now be minus log this 1.8 times 10 to the power minus 5 plus log concentration of salts. What is concentration of salts? It was this 0.09 over concentration of acid, which is 0.003. So we have our pH to be 4.74 approximately, then plus log 3 plus 0.48. So our pH value will be approximately 5.22. Now this is our pH value for question 1. Now question 2 says determine the pH of a buffer made by mixing 400 ml of 0.025 m NH4OH with, this is a weak base, with 600 ml of 0.05 m of its salt. Now let's consider this key done. Let's say determine the pH. We have pH is equal to pKa plus log concentration of acid or equation of base. Now they gave us the pKa of NH3. Now recall that pKa plus pKb is equal to 14. So pKb is equal to 14 minus 4.58. Now why am I doing this? It is because this is a base and not an acid, so we can't use pKa yet. Whereas we can still use this formula, we'll get here at the same time. But let's make it true. So we have pKb will be equal to which is equal to 9.42. Now this is pKb, so therefore POH is equal to minus log. Okay, pKb is given. pKb was pKb plus log salt over acid over base. So now POH will be equal to 9.42 plus log. What equation of salt we have it to be is okay. Now this look at this. We have 400 ml of this. Now we have different volume given. Now in this type of calculation of pH, we just don't use the concentration directly. You have to convert to the moles, the number of mole. Now the number of mole, you place it in place of the concentration. So now what is the number of mole? Mole is CV over 1000 because it is in ml. So N will be equal to for the salt will be 0.005 times 600 over 1000. So we have it to be 3 times 10 to the power minus 3. Then looking at the other one, we have it to be N will be equal to 0.0025 times 400 over 1000. That is 1 times 10 to the power minus 3. So this cancels this. So we have our POH. POH would be 9.42 plus 0.477. We have our POH to be 9.9. Now these are POH. Now I said we should calculate determine the pH. So pH plus POH is equal to 14. Therefore pH is equal to 14 minus 9.9, which will give us 4.1 approximately. And these are pH value for this question. Okay, so quickly let's move on to pH of weak solution. Now they said calculate the pH of a 0.02 molar solution of ethanoic. And they gave us the Ka to be CH3 of CH3COOH as 1.8 minus 5. Now we have to bring out some formula. It is quite different from that of pH of buffer. So we're going to be bringing back the idea of chemical equilibrium to this